the last topic, electromagnetic waves. Okay, see here, if you observe, this is coordinate axis x, y, z, and so on. So this let us imagine to be x, this is y, and this is z here. Okay. So first let us see there is one wave going like this. There is another wave going like this. Now if you observe the green color wave, it is moving in some other plane, and if you observe the one more wave, it is moving in some other plane. Now let me discuss what is going to happen. See here. So this is called as electromagnetic waves. See, what do you understand by electromagnetic? What is this electromagnetic wave? Electromagnetic wave, something new? Nothing. The sunlight is given a technical name which is called as electromagnetic wave. Why it is called as electromagnetic wave? Because it is having electric nature. Okay, so this green color is represented with having electric nature, and this is called as having magnetic nature. Magnetic nature, so magnetic induction, magnetic field, electric field. So here, okay, so now just see, one wave which is called as electric wave is moving in a vertical plane. Another wave is moving in a horizontal plane. So both are moving perpendicularly. One is in electrical, that is along the xy plane like this. Another is moving like this in a horizontal plane. So these two waves combined together, it is called as an electromagnetic wave. This is a name given to our sunlight, electromagnetic wave. Now here, the force acting by both the waves is going to be same here. What is that? Force acting because of magnetic wave and force acting because of electric wave will be same on this wave. What does it mean actually? See, magnetic wave is given by the letter VVQ, sin 90. Whereas the electric field is given by the force formula Q into E. So this is Q gets cancelled. Instead of V, we write C here, that is taken as E. Okay, so instead of E, instead of velocity, we take velocity of light as C. Okay, so therefore, in an electromagnetic wave, the force acting due to magnetic wave and force acting due to electric wave both are going to be same, and it is given by BVQ for a magnetic field. Force because of magnetic field, force because of electric field is given by Q into E. So QQ gets cancelled. BV is equal to E. See, actually this is going to be BV is equal to E. So B into C is equal to E because velocity is going to be velocity of light, which is given by letter C. And you know the value of C is always constant, is going to be 3 into 10 power 8 meters per second here. Understand? And this electric wave is given by a wave equation E naught sine omega t. Okay? E naught sine omega t minus kx. Okay, magnetic wave is given by B naught sine omega t minus kx. Sine omega t minus kx. Okay, so here this is a sinusoidal wave expression is given like this. E naught. What is E naught actually? E naught is said to be the peak value. Peak value means maximum amplitude. See, maximum amplitude is given by the letter E naught, and the maximum amplitude in a magnetic field is given by the letter B naught. Okay, so B naught sine omega t minus kx. E naught sine omega t minus E is said to be a peak value. E is said to be a peak value. This you have to remember here. So when you go in depth regarding a wave, what is a wave equation? How do you get wave equations here? Now just see. See, you all know in a first year you have learned that any particle goes in an anti-clockwise direction. Any particle goes in an anti-clockwise direction with a constant velocity. It is dropped with a perpendicular. Here it is dropped with a perpendicular, and this is taken as the radius of the circle, which is taken as amplitude here. And you also know that angular velocity is nothing but angular displacement by time. So angular displacement is nothing but angular velocity by time. So this angle theta can be taken as omega into t. So this is vertical displacement and this is horizontal displacement along the x-axis. So this is y and this is x. So how do you represent this wave? Just try to understand what is the meaning of a wave motion. What is the meaning of simple harmonic motion? Let us see here now. So let us take this pen represent the particle and this finger represents a component along the y-axis. Now the particle starts from here, your finger starts from here along the y-axis. This is y-axis, no? So now just see, the particle is moving with a constant velocity in a anti-clockwise direction, but your finger is moving to and fro motion just like a pendulum. Same thing happens along the x-axis also. So x component is this one and the particle is moving along the anti-clockwise direction. So the particle will take to and fro motion along the x-axis and the particle will take to and fro motion along the y-axis, and the displacement along the x-axis and the displacement along the y-axis is represented with a letter called as y. So first of all, cos theta is considered as cos omega t. Cos theta, because angular displacement by time is angular velocity, angular displacement is angular velocity to time. So cos omega t, if you consider here, so what is this cos omega t? Cos omega t is x by r. See, this is the radius of a circle where it becomes vertical, it becomes a amplitude. Amplitude means what? This is mean position. This is an extreme position. So particle when it starts from mean position, the most extreme position is this one. Beyond that it doesn't go, it returns back again. So here this is extreme position at the topmost point, this is an extreme position at the bottommost point. This is called as a mean position. Mean means in the middle, okay? So therefore here if you want to find out x is going to be x by a. So this is going to be a cos omega t. So along the x-axis, the displacement of a particle, the component along the x-axis is given by x equal to a cos omega t. Similarly, sin omega t, if you consider, this is sin omega t, opposite side is going to be y and hypotenuse is going to be a. So y is going to be a sin omega t. So therefore, here the displacement along the y-axis, the displacement along the x-axis is represented with these equations. This is the topic of your first year. So how do you explain this first year topic, the extension of this topic in the second year, which is called as a wave motion? Now just see here. See, this is going to be your wave now. This is going to be your wave motion. Now in this wave motion, if you consider the particles here, if you observe here, what is going to happen to the particles? Just see now. Okay, so this is particle number 1, 2, 3, 4 and 5 and 6 and 7 and 8 and 9. See, previously all the particles were resting along the x-axis. So 1 was here, 2 was here, 3 was here, 4 was here, 5 was here, 6 was here, 7 was here, 8 was here. So all were in mean position. But once the wave has entered, the particles have displaced and some of them has gone upwards, some of them has gone downwards. Understood? So this disturbance created because of this wave. So let us consider this time at this place is t dash. For example, a wave has entered at the time 8 am. At time 8 am wave was here. So now the particle was here, the wave was here. Once the wave has entered, the particle has been disturbed and the particle moves downwards. So it has moved from t dash to t here. Okay. So this is 8.0001. It has been like this. Now at the time t 8.00.02. Okay. So is the AM. This is AM. This is also AM. So once the wave has entered, the particle was here. Once the wave has entered, the particle time taken was 8.1 second. So after 1 second again the particle has come down. This is just for understanding. So previously we wrote, if you consider only particle, we wrote y is equal to a sin omega t. But here this is a combination of wave and particles. Wave is moving with a constant velocity, v is constant, and the particles are jumping up and down. Wave is moving like this with a constant velocity, and the particles are jumping up and down. This combination is given by the letter, that is an equation y is equal to a sine omega, okay, t minus t dash will take. Previously you have taken only particle, so sine omega t. Now you have taken wave. Don't neglect this topic. If you don't understand this one, you won't understand 4 chapters. This is wave motion I am explaining. If you don't understand wave motion, you don't understand wave optics, you don't understand electromagnetic waves, you don't understand alternating currents. It's very important. Don't neglect, don't sleep. Okay. So listen here. So y is equal to a sine omega minus t dash. So what is this now? What is this distance? So this distance is taken as the particle is at a distance of x from the y axis. So you know that velocity is going to be displacement x by time t dash. This implies that t dash can be taken as x by v. T dash comes up for x by y, x by v comes downwards. So y is equal to a sine omega t minus x by v is the first equation of motion. Is the first equation of motion. Try to understand this one. Try to remember this one. So here, so I got the first equation of motion. I got the first equation of motion, which is equal to y is equal to sine omega t minus x by v. This is the first equation of motion. So the equation of motion, the equation of wave has born just now. Ipude put in the wave. Then tarvata em modifications unte let us see here now. Oka single wave తీసుకున్నాను. I have taken a single wave here from here to here. So this is taken as what? This is taken as 0. This is taken as pi by 2, and this is taken as pi, which is 180 degrees, and this is taken as 3 pi by 2, which is 270 degrees, and this is taken as 2 pi, which is nothing but 360 degrees. So 0 to 180, 180 to 2 pi. So what is the formula for angular velocity? Angular velocity is angular displacement over time. For one wave, angular displacement is 2 pi and time period is t. So from here to here, time period is how much? T. And what is the distance traveled? Distance traveled is taken as wavelength. Displacement is taken as wavelength. So this is a single wave whose wavelength is lambda. So I got the first formula, which is angular velocity is 2 pi by t, and the next formula, which is velocity is equal to displacement by time, like this. So these are very important formulas. You just remember this one. So omega means 2 pi by t, and velocity means displacement by time, which is taken as lambda by t. So the next topic which you have to understand here is, for every wave you consider, there is one constant which is called as k, which is called as propagation constant. Propagation constant of a wave. Okay, this is very important. A propagation constant. For every wave there is one constant which is called as propagation constant, given by the letter k. What is this k actually? See, you consider that any body is going in a circular motion with a constant velocity. This is the center. Now in this direction, angular velocity. Angular velocity means rotation. Linear velocity means moving in a straight line. Okay. So when this moves fastly, the angular velocity also rotates faster. So angular velocity is directly proportional to linear velocity. Angular velocity is directly proportional to linear velocity. When you remove this proportionality, you will get a constant k, and this k is nothing but propagation constant. So what is the first formula for propagation constant k? K is nothing but omega by v. Omega by v. The first formula is k is equal to omega by v. Just now I told you omega is nothing but 2 pi by capital T. I also told you v is nothing but lambda by t. Therefore k is, so first formula for propagation constant of a wave, that is k, is this one. The second formula for this propagation constant of a wave is what? Let us see here. Okay. Instead of omega, I will write 2 pi by capital T. Instead of velocity, I will write lambda by t. So what is going to happen now? Just see. T gets cancelled. What is the second formula for propagation constant of a wave? K is nothing but 2 pi by lambda is going to be the formula for propagation constant of a wave. Understood? So this is a story of propagation constant of a wave, which is having two formulas. One is k is equal to omega by v. Another is k is equal to 2 pi by lambda, because 2 pi by t to lambda by t gets cancelled. This is the second formula for propagation constant of a wave. Now, how many types of waves we can discuss? Wave equations we can discuss. The first thing is the one which has born, which we have taken sine omega t minus x by v. This is going to be the first wave. So you all know, if I take this sine, okay, I can take omega inside. I can also take omega by v into x. So y is equal to a sine omega t minus omega by v is nothing but k. This is going to be the second equation which we have discussed here. Okay. So this is the second equation and this is the first equation for a wave. Hope you understand what I am saying. This is the wave equation. This is going to be the wave equation. Hope you understand. Is it? So next thing is, okay, so we have discussed about these waves. What is the next topic we have discussed? In electromagnetic waves especially. Let us see here now. See, the first thing is, you have to write the formula for velocity of light. Okay, so you all know velocity of light in vacuum is given by letter C. Velocity of light in vacuum is given by letter C. And that C is going to be 1 by square root of mu naught epsilon naught. Mu naught epsilon naught. You know, mu naught is nothing but permeability of free space. Permeability of free space when you consider the chapter called as magnetism, in which you have learnt already what is the meaning of inverse square law. These two magnets having pole strength m and distance is r. Force is directly proportional to product of the pole strengths. This is m1, this is m2, and force is inversely proportional to square of the distance between them. If you remove this proportionality, you will get a constant that is 1 by 4 pi. What is that? It is going to be mu naught by 4 pi m1 m2 by r square. This is the formula used in magnetism. And another formula is, what is mu naught here? It's going to be permeability of free space. What is the meaning of permeability? Permeability is nothing but it is a medium. So you are, whatever the medium you have considered, if it is air or vacuum, then the medium is given by mu naught. Permeability, name itself says that ability to permit. Ability to permit attraction or ability to permit repulsion. See, when you go to cities like Hyderabad or Bangalore, as soon as the school is over, one girl and one boy comes outside. They both talk together, they go to the bus, they sit together, and girlfriend, boyfriend culture is there in Hyderabad. I was shocked. In the classroom also, both girls and boys are talking to each other. Boy is not talking, girl is not talking, boy is talking with girl. I was shocked. I told, what is this nonsense? What are you doing here? Sit in problem. Yeah, boys. Useless fellows. What is this nonsense you are doing? Is this the way? Boys are there. Girls are there. No? What is the problem? Girl is asking a book for a boy. Boy is asking a book for a girl. What is this? Huh? Why so much of opposite poles are attracting here? I told, this is not the manners. They gave complaint to principal. Principal called me, sir. Here this is a co-education college where strength is full because of co-education only. Do you know why boys are coming daily regularly to the classes without being absent? He is having sneezing, he is having cold, he is having fever, then also he is coming to the college. What is the reason behind that? Because co-education is there. Girls are regularly coming, boys also regularly coming. This is a culture here. So let them talk. You tell them, don't do like this here, do outside. You ask them not to do here, my dear. Tell them smoothly, sir. If you scold them, they will go outside. They will leave the college and the revenue is there because of that only co-education. So that is the surrounding. Why I am telling all these cock and bull stories? Because it is an ability which is called as permeability. Ability of a medium to allow attraction. Here if you tell girl, boy going outside, hey, double. There you know, boy will come to the house. A boy will say, Auntie, college time అయిపోయింది దీప్తి పంపియండి బైక్లో వస్తాడు అమ్మాయి దీపక్ వచ్చినాడు తొందరగా బాబు డ్రైవింగ్ స్లో చేయి ట్రాఫిక్ బాగాలేదు ఈ కాలంలో స్లో అమ్మా కూర్చోపోవాలి జాగ్రత్తగా ఉన్నాను ఇద్దరు చలి బాయ్ ఫ్రెండ్ హియర్ ఇన్ కర్నూల్ ఆర్ బ్రాహ్మణ కొట్కూర్ boy will come, Auntie दीप्ति तेरी माँ की देखती अब देख रे ఏమో కూడా చూడు నీ కూతురికి ఎవడో దీప్తి అని పిలిచినాడు పా అంటే యానా కొడుకు లుంగి పైకి ఎత్తకూడదు ఫస్ట్ గాలి ఆడితేనే మనకి కోపం వస్తుంది అనమాట బికాస్ అవర్ మీడియం ఇస్ లైక్ దిస్ అవర్ మీడియం డస్ నాట్ అలౌ అట్రాక్షన్ అవర్ మీడియం డస్ నాట్ అలౌ రిపల్షన్ దట్ ఈస్ అ పర్మిటివిటీ ఆఫ్ ఎ మీడియం permeability of a medium ability to permit attraction is called as permeability ability to see permittivity is also there what is that if you take one positive charge and negative charge both attract each other okay just like one north pole and one south pole here north pole opposite poles attract opposite charges attract here the medium is said to be of air or vacuum we give with the letter epsilon naught and the formula is force is directly proportional to product of the charges inversely proportional to square of the distance between them when you remove this proportional you will get a constant which is called as 1 by 4 pi epsilon naught q1 q2 by r square so here their mu naught is upwards here epsilon naught is downward this is called as permittivity permit attraction permeability ability to permit attraction or repulsion this is used in magnetism this is used in electrostatics electricity so both are the properties of medium these are not the properties of charges mu naught is not the property of what it's not the property of a magnet it's the property of a medium I have seen people coming from Kurnool to Hyderabad they are studying in Hyderabad they come for studying in IIT colleges there first the girl the boy will be coming with what is that Punjabi dress boy also will come with simple full shirt and pant here and they are very innocent if any sir comes like this they will stay girl also sir like this they will be first starting 2-3 months over dress will change t-shirt will come for girls and that jeans pant will come and girls yeah yes yeah are you sure yeah like that all body language will change boys t-shirt and they will be like models ఎరా చెప్పు ఏం చేస్తున్నావు బే ఏట్రా దమాక్ ఖరాబ్ అవుతుందా పైసలు లేవు బే ఎందుకు పంచే టెల్ బేటా అంటారు సో వాట్ ఈస్ హ్యాపెనింగ్ హియర్ సడన్లీ medium has changed permittivity is also changed so it is not a property of the boy or a girl surroundings will change Punjabi dress bhul gaya daddy idantha katta తీసుకుపోయి యాడ కాల్చు t-shirt pant here t-shirt pant ఏందమ్మా ఈ డ్రెస్ ఏందమ్మా ఏంది ఇది అసలు నా కూతురని మర్చిపోయినా డాడీ ఇట్లా చెప్పినా నా తండ్రిని నేను మర్చిపోతా అంతే బికాస్ మీడియం హ్యాస్ చేంజ్ సరౌండింగ్ సో అండర్స్టూడ్ వాట్ ఐ యామ్ సేయింగ్ నౌ సో బోత్ ఆర్ ఫర్ ఎయిర్ ఆర్ వాక్యూమ్ హియర్ ఆల్సో ఎప్సిలాన్ naught is for air or vacuum here also for air or vacuum we write mu naught so the velocity of light is given by the letter c which is called as c is equal to 1 by square root of mu naught epsilon naught so what is the velocity of light in a medium so it is given by v is equal to 1 by square root of mu and epsilon naught means no medium not epsilon naught mu naught means no medium is there air or vacuum so here some medium is there right mu epsilon naught this is the formula for velocity of light in a medium this is the formula for velocity of light in air or vacuum hope you understand what I am saying now with this you will understand one more thing what is that so from this is the topic of your electromagnetic waves very important chapter very small chapter high scoring 1 or 2 questions will come from this but you can study this chapter within 1 hour nearly 32 questions 30 to 35 questions are there not more than that even PYQs are very less So high scoring with less time. Understand? So what is going to happen now? Refractive index is taken as mu. What is the meaning of refractive index? See, you have taken one medium and you have taken second medium. So the first medium is air, second medium is water. So light travels from air to water like this. It has traveled like this, it has traveled like this. So this is velocity of light in air is always given with C. Velocity of light in medium is given with the letter. What is that letter? V. Okay, so what is the meaning of refraction? Refraction is nothing but bending of light from when it travels from one medium to another medium, the light gets bent. Why it is going to bend? Because sudden change in velocities, sudden decrease in velocities. I'll give the best example for you. Your bike is going on a road, tar road, and there is a sand in middle. Your bike, when it goes from a tar road, when it enters into the sand, your bike suddenly gets skids. It gets tilted, it gets turned. What the reason behind that? Because the sudden decrease in speed creates tilting of a bike. The sudden decrease in the velocity of light makes it to bend like this. That is called as refraction. Refraction is a process where light bends because of sudden change in velocities. Either sudden decrease in velocities or sudden increase in velocities. So, what is the formula for mu? Velocity of light in the first medium to the velocity of light in the second medium. So, this is called as subscript, this is called as superscript. First, it is starting from air, first medium. So, 1 comes as a superscript and it enters to the second medium, and this is called as a subscript mu 1, 2, which is velocity of light in the first medium to the velocity of light in the second medium. So, this is V1 and this is V2. So, V1 is given with C and V2 is given with V. So, therefore, refractive index is given as C. C means what? C means square root of mu naught epsilon naught. C పైన ఉంది, సో ఇది కిందికి వస్తుంది. ఇది V కింద ఉంది, ఇన్వర్స్ రిలేషన్ కదా, ఇది పైకి పోతుంది. So what you getting now? Mu and epsilon. So with this refractive index, this is called as refractive index mu. Okay, లేదా you can give refractive index. Refractive index can be taken as n also, n to 1. So because you may get confusion here, because here mu is also permeability and refractive index also mu. So let us change the symbol here. Refractive index of second medium to first medium is given as C by V. C downwards goes to numerator. So therefore refractive index of second medium with respect to first medium is mu by mu naught, and this is going to be equal to what is that? Epsilon by epsilon naught. So you should know one more thing here. This mu by mu naught is given by mu r. Epsilon by epsilon naught is given as epsilon r. What is the meaning of mu r? It is a ratio of permeability in a medium to that of permeability in a free space. What is the meaning of epsilon r? It is a ratio of permittivity of a medium to that of permittivity of a free space. This is called as relative permittivity. Relative permittivity. This is called as relative permeability. So I have taken the ratio as mu by mu naught as mu r, epsilon by epsilon naught as epsilon r. This question is most asked in electromagnetic waves. Understand? What he'll give? When light travels through the glass, relative permittivity is given as 1. What is the relative permeability of the curve? It is given as 1. And refractive index, that is refractive index of the glass is given as some 3 by 2 like that, isn't it? So why you use this formula now? Mu r is to be found out. Epsilon r is given. Mu is also given. Squaring on both sides, you get the answer. Is it understood what I am saying now? Is it clear what I am saying now? So this is called as one more topic for your electromagnetic waves. What is the next topic here? Let us see the next topic here. See, on any surface, this is one surface. Let us imagine. This is one surface. And this surface is having an area A. This surface is having an area A. Now, this is the sun, okay? This is the sun from which light is coming in the form of waves. So, all the waves will strike on the surface area like this. Understood? All the waves will strike the area. Let us imagine that whatever the light falls on the surface, the total light is absorbed. మొత్తం లైట్ అబ్జార్బ్ చేస్తుంది. There is no reflection. Then what is, see, because of this sunlight, when it falls on some body, it applies some force. It applies some force. We don't know what is that force, how much that force is there. We don't know what is the force. We can find out the force. Whenever light falls on some body, it applies some force, it seems. But that force is not that much that we are going to feel. మనం మీద సన్ పడతానే కింద పడిపోయినాడు అది ఇచ్చేగిరిగా క్యా సన్ లైట్ పడా ఇప్పుడే సూర్యుడు బయటకు వచ్చింది లైట్ పడితేనే దుబ్బినట్లు అట్లా అంత ఎక్కువ ఉన్నాడు నెగ్లిజిబుల్ వెరీ లెస్ బట్ యూ హావ్ టు ఫైండ్ అవుట్ వాట్ ఈస్ దట్ ఫోర్స్ దెన్ వాట్ ఈస్ ద ఫార్ములా టు ఫైండ్ అవుట్ దట్ ఫోర్స్ వెరీ సింపుల్ హియర్ వాట్ ఈస్ దట్ let us see here see first thing is what is the meaning of intensity. Okay, you just remember what is the meaning of intensity from basic. I am telling very important formula. This formula will come in electromagnetic waves. It comes in what is it to be wave optics. It comes in wave optics also. This formula will come in what is it to be dimensional formula in units and dimensions. Very important formula, intensity. Now the wave optics lo intensity formula is there for what is it to be polarization. There also intensity will come. See what is the intensity here? See intensity means power by area. See whenever the light falls on certain surface whose area is A, so power passing per unit area is called as intensity. So intensity means just power by area. So what is power here? Power is nothing but energy by time, or it can also be taken as work by time. Okay, so work by time. Intensity means power by area. Power means rate of doing work. See what is power actually? Power means it can be taken as rate of doing work. See one boy is doing a work in less time, another boy is doing the same work in larger time. One fellow is doing in 10 minutes, another fellow is doing the same work in 20 minutes. Who is more powerful? Who is more powerful? The one who does the work in less time is going to be powerful. Are CM kante PM powerful ra. ఆయన ఆర్డర్ ఇచ్చినట్టు సెకండ్స్లో అయిపోతుంది పని ఆయన దగ్గర పోదు ఆయన రికమెండేషన్ తీసుకున్నాం సీఎం చెప్తే రేపు చేస్తారు రా రేపు అంటే ఆ రేపు కాదు రేపు టుమారో అవునా కదా సో దట్ ఈస్ కాల్డ్ యాజ్ సీఎం పిఎం సెకండ్స్లో సో ఈస్ పవర్ఫుల్ మీన్స్ లెస్ టైమ్ హీల్ డూ మోర్ వర్క్ దట్ ఈస్ కాల్డ్ యాజ్ పవర్. What is the meaning of powerful people? Powerful people just by giving orders the work will be done. We people do hard work. They will do smart work. They are powerful. Understood what is the meaning of power? Power is nothing but work by time. So power, intensity is power by area, work by time. And you also know that work is nothing but force into displacement. Force into displacement. Is it okay? So work done is nothing but force into displacement. You know these are the basic formulas here. What do you understand from this? What do you understand from this? Intensity is nothing but force by area is nothing but pressure, because the formula for pressure is nothing but force by area, and you all know velocity is given by displacement by time. Velocity is given by displacement by time here. So power into okay, what is this? Force by something is missing here. Force by area and displacement. So power into velocity. Is there anything missing here? What I'm saying? Is there anything missing? Everything is okay. Okay. So power into velocity. If you want to find out what is the force acting here, so how do you find out? See, what is this? Pressure, not power. See, power is given with PO. Pressure is given with PR. Pressure means force by area into S by C is nothing but velocity, but we are talking about the light, and velocity of light is given with C. So now one more formula will generate from this formula. Intensity means what? Intensity means force by area, and S by T is nothing but C. So what is the force formula here? Okay, so what is the formula for force? Force is nothing but IA by C. This is the formula which is most used in your electromagnetic waves. He says that intensity of wave is given by 8. Okay, intensity of wave is given by 8 watts per meter square. 8 watts per meter square, because power is in watt and area is meter square. So he has given intensity, and it falls on an area of how much? 2 meter square. Okay, then what is the force? Intensity of light coming from the sun falls on certain area. so and so intensity, so and so area. When it falls and the total light gets absorbed, okay, then what is the force acting on that surface? Velocity of light we need not give, because we already know c is equal to 3 into 10 power 8. It is a constant. It is not necessary that he has to give c for us. We know already. Okay, so this is one formula. When we apply this formula, when light falls on certain surface and it gets absorbed. Okay, the next formula is there is some surface here, okay, whose area is A, and this is sun. This is a sun from which waves are coming, and these waves falls on a certain surface, and what's going to happen? After falling, they will reflect back. Whatever the velocity it moves, with the same velocity it reflects back. Okay, ఏ velocity ముందుకు పోయినో తగిలి అదే velocity వాపస్ వస్తుంది. It gets reflected back. Then what is the force acting? What is the force acting? I'll give one small example. See, you know, force is nothing but mass into acceleration, and acceleration is nothing but v minus u by t. Okay, so which is nothing but mv minus mu by t. Force is nothing but change in momentum. Mass into velocity is called as momentum. mv minus mu by t is called as momentum. See, when it falls and it gets absorbed means initial velocity undi, final velocity 0. When it falls and gets absorbed means there is no final velocity. Final velocity died. Only initial velocity is there. Then we write F is equal to m into, what is that formula? M into v by t. Next part is going to be 0. ఏదో ఒక పార్ట్ ఎగిరిపోతుంది, ఇదో అదో ఎగిరిపోతుంది. ఓకే, సో దెన్ వాట్ హ్యాపెన్స్? Only force is nothing but mv by t. Understood? So this is applicable when you throw a ball on a wall, because there is some gum is there that is going to stick on the wall itself. బాల్ తీసుకుపోయి గోడ కొట్టడం, గోడకి ఏదో గమ్ ఉంది పోయి అతుక్కుపోయింది, లేదా పెయింట్ కొత్త కొట్టినాడు, బాల్ తీసుకుని గోడ కొట్టడం అతుక్కుపోయింది. So final velocity is 0, initial velocity is there. So for example, when a ball is thrown on a wall, whatever the speed you are throwing, with the same speed it returns back. Then what happens? What is the formula for that? ఏమవుతుంది formula for reflection? See, force, the ball falls with certain velocity v, and it returns back with the final velocity which is taken as minus v. So we write this as mv minus mu by t is a general formula, but in this case mv minus of minus v by t. So therefore f is equal to 2 mv by t. So this is when a ball falls and reflects back. So there are two formulas which you have to remember. What is the formula? This formula is applicable when a ball goes and sticks on the wall, and this formula there is double to that of the previous formula. Double. When it strikes and returns back with the same velocity, we write 2. And when it goes, strikes and sticks to the wall, we write only this much formula. So here also the same thing happens here now. Here also same thing happens. The formula, when the light rays falls on a substance, the total light is absorbed. No reflection is there. This formula if applied. And if there is a reflection, falls and returns back, your formula is going to be 2IA by C. Okay, so hope you understood what I am saying now. So this is the second formula where the light falls and returns back. Is it understood? What I am saying now? Clear? That's it. So this is about electromagnetic waves. Now let me discuss one more concept here. The next concept is, what is the meaning of moment of inertia? Very important topic. Many questions are coming on this. What is the meaning of moment of inertia? See here, moment of inertia is given by mr square. For what? Let us take one ring. Okay, there is one ring, and this is the center of gravity. Now this is the moment of inertia. Moment of inertia passing through the center of gravity of a ring is given by the letter mr square, because the radius of the ring is taken as r. Okay, it's going to be r. Just here once again. So this is a general formula. This is, we are talking about a ring. Okay, a ring, circular ring. So this is any bangle you can do for me for 5 minutes. I will return this bangle. Is it not for gold? Because I may not return this gold. Okay, so this is a ring. This is an axis, and this ring is rotating. Then what happens? What is the moment of inertia when the axis is passing through the center and the ring is going to rotate? The formula is I is equal to mr square. This is a general formula. when it is passing through center of gravity. Then what is the moment of inertia when you rotate the ring like this from the edge like this? If this is an axis, what is the formula? So if this is an axis, what is the formula? There is one formula which is called as parallel axis theorem. I'm not going to show you any derivation. I'll give just a simple formula. For example, the distance between the two axes is taken as x. Then you want to find out with some other axis, you know the center of gravity, moment of inertia is mr square. With some other axis which is not at the center, which is at the edge, then the parallel axis theorem says that, okay, parallel axis theorem says that I is equal to Ig plus mx square. So I is equal to Ig. Ig means mr square. Here x is nothing but r, which is also called as mr square. Okay, so which is I is equal to 2mr square. Okay, with what axis? With some other axis which is called as edge. So two things you got. Now what is that? This is called as mr square and this is called as 2mr square. Now I want to find out like this. I want to find out like this. కొన్ని జాతరలో మీరు చూసింటారు, ఒక బ్యాంగిల్ ఉంటుంది, మధ్యలో ఒక బొమ్మ ఉంటుంది, ఇట్లా పైకి వేస్తే బ్యాంగిల్ తిరుక్కుంటూ వస్తుంది, బొమ్మ కూడా తిరుక్కుంటూ వస్తుంది, ఇట్లా రొటేట్ అవుతుంది బ్యాంగిల్. చూసావా? Ring, it rotates like this. So what is the moment of inertia with respect to this axis if a ring rotates like this? The axis passing through center of gravity but parallel to the plane. Try to understand what I am saying now. Moment of inertia passing through the center of gravity parallel to the plane. Moment of inertia passing through the center of gravity perpendicular to the plane. Is it understood what I am saying now? Perpendicular to the plane, parallel to the plane. Okay. So let us see what's going to happen now. So I am applying one formula for you now. So what is that formula? Let us see. So one axis which is passing like this, and one axis which is passing like this, Let us take this as Ix, and this as Iy, and this as Iz. So this Iz can also be taken as Ig. For a ring, it is going to be mr square. Understood? For a ring, it is going to be mr square. So this is Ix and this is Iy. What is the meaning of this Ix and Iy? Let me make you understand. See, this is Ix. Ila rotate chestno. You have rotated with this axis. Now again after that you have rotated with this axis which is called as Iy. This is Ix, this is Iy. So Ix plus Iy will be always equal to Iz. That is called as perpendicular axis theorem. So this is Ix, this is Iy. If you add them, it will be equal to Iz. So what do you understand from this? See, Iz is nothing but Ix plus Iy. See, Ix means along the diameter. This is the diameter, which is taken as Id. Iy is also along the diameter, which is called as Id. So I told you that Iz is also taken as Ig. So Ix means Id. Iy is also Id. So this Id plus Id, 2Id. Ig is nothing but mr square. So along the diameter, what is the formula? Mr square by 2. Understood? What is the formula? Mr square by 2. Along the diameter, it is mr square by 2. Okay? So what do you understand from this? You understood one thing, that if you take a ring and this is parallel to the plane of the ring, passing through the center of gravity, Ig, which is also called as Id, is given by mr square by 2. But I want to find out with some other axis which is called as moment of inertia with respect to tangent. This is called as tangent to a circle. Along this tangent you want to find out. Then we will apply x equal to r. We will apply parallel axis theorem. What are we going to apply? Parallel axis theorem. What is this parallel axis theorem says? It says that I is equal to Ig plus mx square, parallel axis theorem. Okay, so what are we going to write now? I along the tangent, Ig is not this Ig is mr square. This Ig passing through the center of gravity parallel to the plane. This is Ig passing through the center of gravity perpendicular to the plane. So this Ig is given by mr square by 2, and here x equal to r, again mr square. Therefore along the tangent we write it as 3 by 2 mr square. Hope you understand. Everything is over. Now if you take a ring, three things, how many formulas you have learned from this ring? You just see. I'll repeat this and you have to tell me now. Okay, so what is this formula for Ig? क्या बेटा? कितना? mr square, yes. With this 2 mr square. With this mr square by 2. With this 3 by 2. Okay, 3 by 2 mr square. Once again, what is this? Mr square. What is this? What is this? And what is this? Okay, you are perfect in a circle now. Now you have to do the same thing for a disk. For a disk. Now there is no risk because we are discussing about disk. You already know ring. During ring we have discussed. So for disk, no risk. So I have taken a disk now. I have taken a disk now. Disk means in the middle also there is a mass. Then I have taken one line which is passing through the center of gravity. This is going to be an axis. So Ig for a ring, for a disk is basic formula, it will not change. Basic formula is not going to change. It is called as mr square by 2. For a disk, for a ring it is mr square. For a disk it is mr square by 2. It is half of the ring. Ring can count the second formula here. Okay. Now I want this axis here. Now where x is going to be r, then what is the moment of inertia with respect to some other axis which is along the edge? So you just write the parallel axis theorem, Ig plus mx square. So Ig is nothing but mr square by 2 and x equal to r, so this is mr square. So this is taken as 3 by 2 mr square with some other axis. Okay, now let me apply this. Let me apply this for tangent also. Let me apply for this for tangent also. What is this? So I have taken a disk now. I have taken a disk. Okay. So in this disk, this is going to be one axis. This is going to be another axis, and this is going to be this another axis. So what is this? So this is called as Ix, which is called as along the diameter. This is called as Iy, which is along the diameter. Okay. And what is this? This is called as Iz, and Iz is nothing but Ig, which is called as, what is Ig? This is the basic formula for Ig, which is given by mr square by 2. Okay. Now parallel axis theorem. What is the meaning of perpendicular axis theorem? Perpendicular axis theorem says that moment of inertia with respect to z is moment of inertia with respect to x, moment of inertia with respect to y. What is the meaning of this perpendicular axis theorem? If you rotate some body along the x-axis and if you rotate the body along the y-axis, for example, this is 2 units, this is 2 units. If you rotate with this, it will be 4 units. That means addition of along x-axis, addition with along y-axis will be exactly equal to along the z-axis. That is called as parallel axis, perpendicular axis theorem. So here, what do you understand? Ix is nothing but Id, Iy is also nothing but along the diameter. So it's also Id. So what is Ig, Iz? Iz is nothing but mr square by 2. Therefore, this implies that 2Id is mr square by 2. This implies that Id is equal to mr square by 4. Understood what I am saying? So for a disk, along the diameter, if you observe, which is passing through the center of gravity, so Ig along the diameter is how much? Mr square by 4. I want with some other axis, which is called as along the tangent, and the distance is x equal to r. Then I want this one, and you know that the formula is I is nothing but Ig plus mx square. See, Ig is already known to you. Mr square by 4 plus mr square. So what is the answer? I is equal to 5 by 4. Mr square is going to be your answer. Is it understood to you, my dear? Now, let me repeat this once. This is a disk. This is a disk. If it falls, no risk. Okay. So this is what for a disk? Mr square by 2. What is this? 3 by 2 mr square. What is this? Mr square by 4. Along the diameter. Along the tangent. 5 by 4 mr square. Hope you understood. Once again, let me tell. What is this? Huh? Mr square. Very good. Now, for a ring. For For a ring along the diameter. Very good. M square by 2. For a disc along the tangent. For a ring along the tangent. For a disc along the edge. For a disc along the edge. 3 by 2 M square. Very good. For a ring along the edge. 2 m square. So you should be very fast. Now, let us solve the problems which are coming from previous years. See how easy it is. Now, so you have taken one ring, another ring, 3 rings are there having same radius, and you have taken an axis passing through the 3 rings. Now, what is the net moment of inertia if 3 are the rings here? So, tell me now. See, what is the moment of inertia of this? What is this? Yes. What is the moment of inertia for this ring which is passing through the diameter? Ring. This is m square by 2. For one more ring along the tangent, ring, tangent, 3 by 2. 3 by 2 m square. This is also 3 by 2 m square. Add them now. Net means what is that net? See, this is 1 plus 3 plus 3. No? M square by 2 is common. 1 plus 3 plus 3, how much? 7 m square by 2. Understood what I am saying now? So m square by 2 plus 3 m square by 2 plus 3 m square by 2 means m square by 2 is common. 1 plus 3 plus 3 is nothing but 7 m square by 2. Is it understood? This is about the 3 rings. Now, if you consider 3 discs, now all are the discs. So, what is the moment of inertia for this disc? Tell me now. Along the diameter level, what is the answer to that? Very good. This is m square by 4, and this is how much? 5 by 4 m square, and this is. So what is I net? 11 m square by 4 is going to be our answer. Now, one more thing let me discuss. If you have taken a solid sphere, so this is a solid sphere, అంటే మొత్తం లోపల కూడా mass ఉంటుంది, nothing local inside is also there is a mass. So this is a sphere. Now, what is the moment of inertia when this is going to be the center of gravity? Okay, so this is going to be the center of gravity. Okay, and what is the moment of inertia for a hollow sphere, solid sphere? It is nothing but 2 by 3 m square. So you will apply some other axis that is along the tangent, so which is nothing but Ig plus mx square. X is nothing but radius of the sphere, so we write this as I is equal to Ig. Ig is how much? 2 by 3 m square for a sphere, and this is also m square, so your answer is how much? 5 by 3 m square is the formula along the tangent. 5 by 3 m square. You can apply only parallel axis theorem for sphere, or perpendicular axis theorem you can't apply for 3-dimensional figures. Only 2-dimensional figures like ring, disc you can apply perpendicular axis theorem, but a sphere you can't write. Okay, ఒక ప్లేట్ ని చక్కగా పెట్టినావా ఉల్టాగా పెట్టినావా చెప్పొచ్చు ప్లేట్ ని, బికాస్ 2-dimensional ఫిగర్. ప్లేట్ ని ఎలా ప్లేట్ ఉల్టా పెట్టినావు చక్కగా పెట్టుకు తినంటాం. ఒక బాల్ తీసుకొని పెట్టినా నేను, సార్ బాల్ ఏంటి సార్ ఉల్టా పెట్టినారు? అరే ఎదవా, బాల్కి ఉల్టా చక్కగా ఉంటుందిరా, రౌండ్ కదరా, అది ఎక్కడ పోయింది? బాల్ కూడా ఉల్టా చక్కగా ఉండదా? సో దట్ ఈస్ నాట్ ఎ 2-dimensional figure. It's a 3-dimensional figure. Hope you understood what I am saying now. Is it clear? So this is about the solid sphere. Now let me go for the hollow sphere. Hollow sphere means inside it is empty. The radius is r, so which is passing through the center of gravity. So what is the moment of inertia with respect to gravity for a hollow sphere? See, I have told a little bit wrong, my dear. I am sorry. This is 2 by 5. Okay, 2 by 5. This is also 5. So what is this? 7 by 5. I'm sorry. This is 7 by 5 mr square. Solid sphere the moment of inertia takku untadi 2 by 5. Denominator is more takku untadi. Hollow sphere is more. Okay, so it is going to be for a hollow sphere it is going to be through 2 by 3 mr square. With some other axis if you consider where x equal to r, we write I is equal to Ig plus mx square. Mx square and mr square. Ig and enta ikkada 2 by 3 mr square plus mr square, which is nothing but 5 by 3 mr square. For a solid sphere it is going to be 5 by 3 mr square. For a hollow sphere it is 5 by 3. For a solid sphere it is 7 by 5 mr square. 7 by 5. Okay, so this is the formula for solid and hollow. So now if I give formula, if I give the 3 spheres, 3 solid spheres are like this, 3 solid spheres are like this, and with respect to this axis, what is the net moment of inertia? Can you tell me for a solid sphere? So what is this? Solid sphere 2 by 5 mr square. What is this? 7 by 5 mr square. And what is this? 7 by 5 mr square. So what is the net one? Mr square by 5 is common kada. Okay, so 1 plus 7 plus 7 16 by 5 mr square. What is this? Solid sphere. What is this? Solid sphere. So if it is a 3 hollow spheres, ఇదే hollow sphere అనుకో, ఏమైంది ఫార్ములా నేను గ్రీన్ కలర్ తో రాస్తా ఫార్ములాస్. సో గ్రీన్ కలర్ తో రాస్తా. దిస్ ఇస్ 2 by 3 mr square. దీని ఎంత? 5 by 3 mr square. దీని ఎంత? 5 by 3 mr square. ఇప్పుడు ఇది hollow sphere, not a solid sphere. So what is I net for a hollow sphere? See, mr square by 3. Mr square by 3 is common. So 5 plus 5 is 10. 10 plus 2 is 12. So this is going to be 4 mr square. Is it understood what I am saying now? Yes. Now let me discuss about one more thing here. So I have taken one rod. Okay. You know the rod. This is G. So moment of inertia for a rod is how much? ml square by 12 if the length of the rod is L. ml square by 12. ml square by 12. I want the moment of inertia with respect to some other axis where x equal to L by 2 here. It's not R, L by 2, sagam, half length. So what is your formula with respect to some other axis? This is Ig, which is nothing but Ig plus mx square. Ig is nothing but ml square by 12 plus mx square. ml square by 4. We'll be getting ml square by 3 as the answer. Okay, understand what I'm saying now? Is it clear? Is it clear? Yes? Okay. So now, for example, I have taken one ring. This is the center of gravity of the ring where Ig is equal to mr square. I want some other axis where x equal to r by 2. It is not the edge, in the middle only. Then what is your formula? Here Ig plus mx square, where Ig is set to be mr square, and this is going to be mr square by 4, which is nothing but 5 by 4 mr square. 5 by 4 mr square. Understood what I am saying now? So he may ask in the middle also, x by r by 2, లేదా r by 3 ఏదైనా అడగచ్చు. So this is a story of moment of inertia. Hope you understand what I am saying now. Is it clear? Moment of inertia.